Assalamualaikum. My name is Yasmin Sumaya binti Muhammad Multazam, metric number 1240846. In this presentation, I will present my automated Excel simulation model for SMA2033 Financial Mathematics. My presentation will cover two main areas. First is modeling a multi-stage property financing package for Amir and Sarah, incorporating interest accumulation, amortization, and debt acceleration strategies. The second one is evaluating two corporate investment proposals, Project Seri and Project Bakavali, using capital budgeting and appropriate techniques. So first is we're going to go to question 1. For the first question, it asks us to calculate the monthly regular installment. So as we can see here, this is the monthly payment or monthly regular installment, and this is all the information that is mentioned in the question that I put in the table. So the initial principal is 300,000 ringgit, and the effective annual interest is 4.5%, and then the total tenure in years is 30, and because it is a monthly payment, so per year we pay 12 times. And then the repayment holiday in months, as mentioned in the question, is also 6. And then from month 7 to month 36, it is interest only period. So the total months from month 7 to month 36 is 13. Then I calculated the monthly interest rate since we needed to calculate the monthly payment. This is using this formula, which is 1 plus 4.5% to the power of 1 over 12 minus 1. Then the total tenure in months is 360, which is 30 of the total years times 12, which is the times of payment per year. So we get 360. Then the balance after 6 months is calculated using this formula of the initial principal times 1 plus the monthly interest rate to the power of repayment holiday. The balance after 6 months is 306,675.72, because during the 6 months the Amir and Sarah doesn't need to pay the monthly payment. Only the interest is compounded. So the value will be this. Then for the remaining amortization periods is the total of 360 minus the repayment holiday and the interest only period. So we will get 324. In years it will be 27. And then we can use this formula, which contains the monthly interest rates and also the balance after 6 months and the remaining amortization period. Question 2, I will explain the loan amortization schedule. My spreadsheet schedule is structured into 6 dynamic columns, which is period, payment amount, interest paid, principal repaid, extra payment, and outstanding balance. For months 1 to 6, both payment amount and extra payment remain at 0 due to the repayment holiday. Even though no cash payment is made, monthly interest accumulates and gets added directly to the loan balance. As a result, the outstanding balance increases every month during this holiday period. From month 7 until month 36, Amir and Sarah play on the monthly interest, so the regular principal repaid remains at 0. However, because extra payments begin in year 2, the outstanding balance still decreases during this period whenever an extra payment is made. For example, extra payments occur in month 13 and month 25, which directly reduce the principal balance during this interest-only stage. Starting from month 37, regular equal installments of 1,620 ringgit 83 cents begin. Each installment is split into 2 components, the interest portion and the principal portion. Part of the payment covers the monthly interest, while the remaining balance pays down the principal. As the principal balance reduces over time, the interest charge shrinks and the principal portion goes larger. In addition, the extra payment column continues to track annual lump sum principal reductions in the remaining years. When an extra payment occurs, it directly reduces the outstanding balance on top of the regular monthly principal repayment. This allows the amortization schedule to dynamically update and shorten the remaining balance row by row. So for question number 3, it asks us to evaluate and find the minimum possible financing term that can be achieved through this strategy. So since the payment stops at 146 months, which is 12 years and 2 months, the minimum possible financing term is 146 months, and the total time saved is 214 months. So for phase 1, months 1 to 6, repayment holiday. During the initial 6-month holiday period, Amir and Sarah are not required to make any regular payments. However, interest continues to accrue on the initial RM300,000 principal balance. For phase 2, months 7 to 36, which is the interest only and first payment. From month 7 to 36, the payments only cover the interest accrued each month, leaving the base principal untouched. Though in month 13, the start of the second year, the annual prepayment starts. Amir and Sarah make their first lump sum prepayment capped at 10% of the opening balance of that year. For phase 3, months 37 to 145, the full amortization with annual 10% prepayments. Starting in month 37, the regular full monthly installment of RM1,620.83 begins paying down both principal and interest. To maximize debt acceleration, the 10% lump sum prepayments are continuously executed at the start of each subsequent year, which is months 37, 49, 61, 73, and more. Calculated based on the opening balance of each respected year. Combining regular monthly amortizations with this annual maximum extra payments quickly reduces the outstanding principal balance. So for the final phase 4, month 146, the final settlement. By month 146, the remaining principal balance drops to a residual amount of 18 ringgit 31 cents with the final month's interest of 0.07 ringgit. Added to the required final payoff amount is 18 ringgit 38 cents, making this final payment of 18 ringgit 38 cents completely clears the remaining debt, fully liquidating the mortgage 214 months ahead of the original 360 month schedule. Next, I will present question 2. To begin, I set up the projected annual cash flow for both opportunities inside the spreadsheet. After that, I calculated the annual discount factors using the standard formula. So here is the year-end cash flows from the given info, and then this is the formula for the discount factor. 1 divided by the sum of 1 plus the interest rate raised to the exponent of the year number. Here is the interest rate. This formula allows us to convert future cash streambacks into current ringgit values based on the 4.5% target rate. To illustrate, year 1 yields a discount factor of 0.9569. Notice how this factor drops year after year, illustrating that future cash flows carries lower purchasing power today. For the present value calculation, with the discount factors established, I computed the present value for each year's cash flow. The formula applied is present value equals to cash flow multiplied by the discount factor. Taking Project Zeri as an example, the year 1 of outflow of 500,000 ringgit gets scaled by the year 1 factor, resulting in a present value of negative 478,468 ringgit 90 cents. I carried out this identical calculation across all years for both options. Here is Project Zeri, and here is Project Bakar Bali. For net present value, following that, I determined the net present value. We get the NPV by adding up every discounted cash flow across the full project lifetime. I verified these figures using Excel split in NPV formula, which confirm my manual totals perfectly. For Project Seri, the net present value comes out to RM498,373.64. For Project Vakavali, the net present value comes out to RM485,516.15. Because both numbers are positive, both investments are financially viable and would add value to the enterprise. Even so, Project Seri delivers the higher overall NPV. This proves that Project Seri adds greater total financial value over the long run. Moving on, I calculated the internal rate of return, commonly known as IRR. I applied Excel's native IRR function, which solves for the exact discount rate, where net present value drops to 0. For Project Seri, the calculated IRR is 9%, and for Project Vakavali, the IRR is 10%. Given that both results surpasses 4.5% hurdle rate, both proposals satisfy our basic yield threshold. While Project Vakavali achieves a slightly higher percentage return, IRR should not be relied upon its own due to non-conventional cash flow distributions. Next is for question 3, which is calculating the present value payback period. This metric estimates how many years are required to fully recover the original cash outlay on a discounted basis. To perform this, I allocated the final year showing a negative cumulative present value. For example, Project Seri is year 16. I then took the remaining uncovered capital and divided it by the incoming discounted cash flow of the next period. Lastly, I added that fraction to the final negative year count. So here is the formula. For Project Seri, the discounted payback period equals to 16.6 years. For Project Vakavali, is 13.4 years. As a result, Project Vakavali pays back its initial capital faster than Project Seri. For the final decision, I evaluated the overall decision based on all three metrics. First, looking at the internal rate of return, Project Vakavali achieves a slightly higher rate of 10% compared to 9% for Project Seri. This shows that Vakavali yields a better percentage return on the capital directly locked in the project. Second, looking at the net present value. Project Seri generates a NPV of RM498,373.64, which creates a RM12,857.49 more absolute wealth for the firm than Project Vakavali's NPV of RM485,516.15. Third, Project Vakavali offers a shorter discount payback period by recovering its initial investment of 13.4 years, which is 2.76 years faster than Project Seri's 16.16 years. In summary, even though Project Vakavali leads in terms of recovery speed and IRR, Project Seri remains the superior choice. In corporate finance, the net present value rule strictly overrides other two criteria because the primary objective is to maximize total shareholder wealth. Project Seri delivers the greatest net economic value to the corporation today. Additionally, the NPV is a far more dependable decision tool because it assumes intermediate cash flows are reinvested of the firm's 4.5% target hurdle rate. In contrast, the payback period is limited because it ignores all the highly profitable cash inflows that Project Seri generates in its later years. Therefore, I strongly recommend Project Seri for this investment opportunity.